When we were involved in the early stages of game development, what this would eventually be. We were just looking to do something different, something unique. And so what I'm going to do is kind of tell you the stories as they roll out of the Vectrex. If we have time, I'll tell you little stories about Microvision, which actually preceded Vectrex. And then I'd love to get some questions, find out what you'd like to talk about. The Vectrex itself started one time at lunch when some of our programmers and designers, as they would do, went out to lunch and went to an Army-Navy surplus store. That was a big part of lunch, going there to see what they could find, and they brought back a 1-inch diameter CRT. It was about 1 foot long, and it was an old instrumentation unit from an airplane. I don't know what it was used for, but that's what they said. And wouldn't it be great if we could put a little game on that CRT, that big like that? Maybe even a handheld game or something like that. So move ahead 2-3 months, a lot of discussion, a lot of this, a lot of that, a lot more trips to the Army-Navy surplus store. But we came up with a product that we called Mini Arcade. And the idea was a vector scan game on a 5-inch CRT, and we put it together with a connection out to a videotape player, so you can play a game on there, and sold it as a project to Kenner Toys in Cincinnati. We did a lot of business with Kenner, and they had done an awful lot of things, particularly the Star Wars stuff they were noted for. And so we worked with them, trying to make it go, and about 4 months later, they said, no, that's just not for us. We're a toy company, we don't really think we'll compete in this area. And we then took it down the street. Our office was in Santa Monica. We took it down to Ed Krakauer, who had a little company called GCE. And we had done, Ed used to work with Mattel, headed up the Intellivision program at Mattel for a while, then moved on, and had started his own company. We'd done a game watch for him, a game calculator, and said, how about this? And he fell in love, said, let's do it. This is about September of '81. He said, let's do it and present it at the Consumer Electronics Show in Chicago, June of '82, and put it on sale at the end of '82 for Christmas. He said, sure, why not? Develop a whole game system, 12 games and so forth, 9 months, piece of cake. Well. Out of that came the, it has to be larger, so it was made a 9-inch screen. We took it and turned the screen sideways for a TV. This is a 9-inch regular black and white TV screen. We sourced in the Orient, $8 or $9 or something like that. And it turns out that was cheaper than the 5-inch screen and cheaper than a 15-inch screen. So this was the ideal thing to try to get it into the price range. And started out on the quest to make this go. Why vector scan, you would ask? Why not just raster scan? In 2 words, zoom and rotate. If you remember back then, how do you make an object larger? You pull up another object from the memory and put it in there. How do you rotate it? You pull up another object from the memory. In vector scan, you just tweak some numbers. It's wonderful. So, and also there were a couple of outstanding games out there, not the least of which was Asteroids. It was showing all those things really, really well, and besides it was different. So away we went. The interesting thing about how do we get then to put a game up there, the first games that we tried were on an oscilloscope. You know, an oscilloscope is vector scan, moves it along. So by varying the voltages in and out at the proper times, we could get game images on the screen. We had to take the tube that would present the image and put a different set of electronics on the tube. If you know a TV is raster scan. You take the beam, run it across, turn it off, run it across. 30 times a second, then you'd run it interlaced another 30 times. So 60 cycles, I'm dragging out of the memory. But to get that on, then you vary the brightness of the beam to make the picture up there. And interestingly enough, there was a video game patent by, turns out, a friend of mine and a real pioneer in games, Ralph Baer, who pioneered in a raster scan environment a video game. And I'm sure many of you heard about it, but this Ralph patented the video game, and the key to his patent was detecting collision or detecting overlay of two objects. And you really can't have much of anything if you don't get two objects together, whether you're batting them, swatting them, steering them on a road, doing anything. You have to know when two objects on the screen are there. That's the basic video game patent he got. Sold it, his company took it over, that he was in the military, for Saunders Associates. They licensed it to Magnavox, which was taken over by Philips, and that became known as the Philips Magnavox patent, and probably hundreds of millions of dollars of royalties ended up being paid. Only a few got to Ralph. But I digress. There's only one video game system that's ever been done that was not covered by that patent, and it was Vectrex, because it wasn't in a raster scan video system, it was in a vector scan. So we proceeded on in developing that. We identified and developed 12 games and presented the prototype units and the 12 games at the Consumer Electronics Show, I think it was June of '82. And what were some of the features that really began to make that unique, and what are some of the limitations? One of the things is, in a vector scan environment, you draw a line, and if you draw the line more than X number of inches, or keep drawing for more than something like 20 milliseconds, the line begins to disappear. So you're limited in how many lines, total length of lines, you can draw on the screen. That limits the amount of items you can have on the screen. And it also has another problem in text. So if you go and look at the Vectrex, you get a chance to look at it, you'll see that many of the screens, instruction screens, starting screens, and so forth, have text on them. And if you're to draw text with a T, H, E, look how many lines you've drawn just to say V. You run out of energy real quick. So two of the key guys in this whole project, there were many, 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 Jerry Carr and John Ross. John Ross did a lot of the key analog electronics for the electron beam. Jerry Carr did a lot of the digital electronics, and one of the schemes that they came up with, Jerry did, was to draw a raster scan little box for text. So he drew 7 lines and turned the beam on and off, and you could put text out on that line. That way you only drew 7 lines instead of 23 or 123 for a line of text. One of the interesting considerations was what processor do we use there? How big of a ROM is in there? And I think we wound up with the 6805.
6805, 6809.
6809. 6809 was it? I've forgotten all the trade-offs we went through, but there was a lot of consideration about Intel processors, Motorola processors, which version of the Motorola processor, and what would have the longest life after we started, what could you add on and do the most things with. And it turned out to be a great choice, because you can see in the museum in there all the things that have been done with it since, and then the things that got done with it during its original lifetime. And the other consideration was, you sell the unit, like an Atari, and then a cartridge for the basic game, much less expensive to put in the ROM built in inside. And so we had, I believe, an 8K ROM. Check with the most recent experts.
There's an 8K, there's a 4K ROM that was also in there in some of the games.
And yeah, the games had 4K, usually had 4K, but the base unit, I think, had 8K, right. 4K for the operating system, and 4K for the basic game, which was a sort of shameless knockoff of Breakout. So then we had, the basic decision was that every unit would come with the same game, at least for the initial production run of the initial basic game. Another thing that allowed us to do, the choice of the 6809, is apply some technology that we've been using in toys, which is to store by delta modulation a voice. So we took, and as you remember, Spike, Spike and Molly, and recorded some voice, and in that 4K, or that portion of the 4K ROM, put a little voice effort in there. And that was one of the first talking video games, where you say, Molly, remember Spike, and what he used to cry out. So one of the other key things in the development of it was the analog electronics. In a regular CRT, the beam just goes back and forth. We built our own high voltage system to be able to control the beam a little bit differently for the vector scan system. So when you get inside a Vectrex, you'll notice that it has a kind of a unique high voltage system. And then we also put different coils around the TV tube to control the movement of the beam. The beam in a regular CRT raster scan has to go sideways at a very monotonous back and forth rate, but it doesn't go up and down and pause and move all over. So we developed and did our own coils. So if you look around, again, on the side of the neck of the tube, you'll see the special coils that we did to move the beam to our specifications so that it could make a vector scan. The interesting story about some of the games that went on there initially was not so much a Vectrex story, but a story of game development in the early stages of video games. I don't know how many of you are familiar with the dust levels that you get into if you're playing the basic game that came with the unit. In our design, in our wonderful, very talented designers, the best they could do as the game was initially done is to get up to about level 9, maybe level 10, when the mines were shooting back at you and you were shooting at them. It's moving all around, and the game, they said, well, what we'll do is figure that maybe somebody who's a superstar could get to level 11, and then we'll put in level 12 and 13, and they'll be impossible. Nobody will ever get there, but we'll put them in anyway. And it wasn't but about a week after the game was released to the public that we found out a couple of calls. What happens after level 13? What do you mean? And it turns out my young son was also one of those. And, oh, what a shock. So as many of you know, really good gamers could get through level 13, and then by blind luck, it didn't blow up completely. It went into what then became called the dust levels. It wasn't planned for, it wasn't programmed, it just happened. The mines reduced themselves to specks, and yet they still had sort of some of the characteristics of the moving mines in the other games. And I don't know the full story. I guess people have gone up, I've heard as high as 28.
I've heard as high as, rumored, not confirmed, as high as level 39.
And none of them are programmed, none of them are planned, nothing there. It's a complete accident. Absolutely amazing story. Very embarrassing at the time, and you can imagine a lot of scrambling and so forth. And then it was eventually repaired and put out as new and improved. It had a stop at 13. But that was one of the unique features of that. Then after the first 12 games and it got launched, GCE was bought by Milton Bradley, and they took over and began producing a number of the later games that went on. They did the 3D, the light pen, the music, and some of the other things. And we concentrated on what could be the next iteration of Vectrex. And we then looked at what could we do to make it color. Now it's black and white. Admittedly, it has the little color screens on the front. That was an crack-hour must be there, especially for TV and packaging. It has to look, because with that on and with the screen in front of the TV tube, the color screen, transparent color screen on the package and in TV commercials, it looks great. And sort of as an aside, did you, has anybody ever seen the Jackie Stewart TV commercial? You know, the guy who was a championship road racer? He made a TV commercial from that. That was unbelievable. And since seeing some of the original, I've never seen a copy of it.
No, as far as what we have currently in the archives, we have one of the original Vectrex commercials, but it's just the typical product placement, but not the Jackie Stewart commercial, not yet. So if you have it in your storehouse of information,
Maybe I can get
love to
it from Milton Bradley. There's still a few guys still there who remember those days. But the next step obviously is, what can we do for color? And we scratched our head and worried and wondered. Even then, they were essentially doing the razor and blades thing. They were losing money on what they were doing is selling the base unit, or certainly not making any money from trying to make it up on all the cartridges. They ended up, as you know, getting caught up in the 83, 84 crash of the whole video games area. But before that, we had worked hard on what can we do to make a color Vectrex. So first thing you do is, of course, look at a color tube. And a color tube, impossibly expensive. It's 3 guns and a matrix and a this and a that and the other thing, at least 3 times as expensive as a regular black and white tube. And then it had 3 times the electronics inside. It was a non-starter. So we looked at the regular black and white tube that we had and thought, well, what happens if you put 2 layers of phosphor on the tube instead of a white layer that when the electron beam hits it goes white, makes a white line? Why don't we put in a red layer, let it dry, and put in a green layer? And if we vary the power of the electron gun, maybe it'll hit one layer or go through that layer and hit the other layer. And we convinced the TV tube maker in the Orient to do that. He sent us a couple of samples. We put one together, and sure enough, it worked. And so there, right near the end of the run, we produced a color Vectrex that could do green lines, red lines, and something in between, depending on where the power of the electron beam was. Now, the limitation on that is that I'm not an analog electronicer, but to control the power of 18,000, 16,000 volts and rapidly switch between the two is quite a trick. So at best, you can switch sort of fast between the two. So you would start out drawing a line, and it would be green, and then you'd switch at a point to draw a red line, and it would slowly go along the line from red to green. But it got there. It created the effect pretty neat. And so there is a color unit in the...
There's a color unit. It's on display over in the museum right now, along with a few of the original color games. So
there was something there. It didn't quite make it out. As everybody knows, then in '83 and in '84, the whole video game industry collapsed in on itself. Too many terrible games at no money-making opportunity at all. And the trade, the retail trade, had always been, this was new to the retail trade. They dealt with board games and cards and things like that. These electronic things were always kind of scary to them anyway. So when the sales began to fail, they said, oh, okay, that's it. Electronics is over, on to the next. And it was really Nintendo that kind of resurrected that over the next 5 or 6 years. That's a whole other story in games. So if you have some questions on that, save them for just a little bit. And let me tell you about one more project that we did that's sort of related to Vectrex, but preceded it, and it was called Microvision. And Microvision turned out to be the first handheld LCD game with a graphic matrix. In the era when that was created, LCDs were just replacing LED displays in calculators and other things that printed numbers and letters. And in an LCD, a quick technology of LCDs, it's 2 glass panels with liquid crystal material trapped in between. And the panels have polarizers on them, so you can't see through them. Like this you can see through, this way you can't. And the liquid crystals twist the light. So when an electronic trace on the inside of this one, an electronic trace there, When those are energized, the crystals in between twist and the light goes through or is let in and out to be reflected. So that's sort of the way a liquid crystal works. And the limitation, if you're going to create an image, you draw the image in the electrical material, the invisible trace that's there, and you light up the image, and that's fine. But if you're going to do a graphic display with dots, you're okay on all the dots in one row or all the dots in one column. You turn on the column, and you can then do 1, 3, 5, and 9. You can put on those rows. And the same in rows and columns. You put on row 1, you can light up A, D, E, and H. But it's the diagonals that are the problem, because if you light up A, you put on A and B, and 1 and 2, you get 4 dots, not 2 diagonal dots, you get 4 dots. So how do you do the diagonal? You light up A1, shut it off, light up B2, shut it off, light up C3, and you get these 3 dots, but by the time you get to CD4, dot A1 has faded out. So that was the limitation of a graphics display, and that was so we proposed doing a 16 by 16 graphic panel. 1978, something like that. Unheard of, can't be done, don't bother us. We ended up making our own LCD, doing a little chemistry to modify some LCD material, and developing a computer-oriented scan system in all the calculator display. There was row 1, row 2, row 3, row 1, row 2, row 3, and each for 20 milliseconds or something like that. Sounds simple now, but we developed a computer technique so you could do row 1, row 8, row 10 for a long time, then row 3, and if you think of the first game that came out, our name Blockbuster, it had 2 or 3 rows of bricks. 1 row moving was dedicated to the ball and 1 row to the paddle. So we didn't have to light up all 16 at any one time. And with this computer-controlled row scan, we got a patent on it. It allowed us to do this idea for the Microvision system. So we put this together in a concept, got a special driver made. Hughes, I think, made the driver.
I think.
Don't remember. It was even a big deal to get that made. Then we were going to do cartridge programmable. What a concept, cartridges. But it turns out it was much less expensive to put the computer with its own self-contained ROM in the cartridge. So all of the Microvision systems had the computer with a self-contained ROM in the cartridge. There was no computer in the base unit, only a driver for the display. And so out of that came this whole series of games from Milton Bradley. Bless them for supporting that and getting it there. They were against licensing. We were proposing the first game that would come out would be Space Invaders. And it came out with Blockbuster, which was fine, but that wasn't a well-known name. You had to say, ah, yes, that's a knockout or breakout, I know that. And that turned out to be just an amazing machine. Created quite a bit of waves in the industry. It was the first handheld cartridge programmable game, blah, 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 and all that sort of stuff. And sure enough, going into that, we decided, well, you got to do something in color. How do you do a color LCD in 1980? They didn't exist. So, some clever guys in my group came up with something called a quarter wave plate. And remember, I talked about how the LCDs work on the provision of polarization, like this, and the crystals turn it so that it effectively is like that. But if you put in, instead of the polarizer on one of these, a quarter wave plate, the term quarter wave has to do with the light going through a quarter of the wavelength of the light will produce a color. And if you can take those crystals and turn them half on, you get one color. 3/4 on, you get another color. And full on, you get yet another color. Does have to be backlit because this doesn't allow for anything going through and reflecting. So for Milton Bradley and that early time, we ended up making a handheld Microvision unit that had a mirror that you could click out the back to catch the room light coming through, quarter wave plate, and you could play games in color on Microvision. Never made it in production. They weren't sure exactly, well, now, why would anybody really want a color handheld game that cost a lot more money, you know, especially not one named Game Boy or something like that. And that turned out to be the sort of the trip through those two products. One of the interesting things that came out of that is I got to go and give some lectures to Palo Alto Research Center, given the Xerox area. They called me up, come on, what are you doing with these LCD displays that you can get 16 by 16 on? So I gave a talk to them and went up and talked to Northern Telecom up in Canada. They were doing stuff, trying to get breakthrough into simpler areas. I've got stories of actually even more products, but what I thought I'd do before that is see what kind of questions you have about Vectrex and or Microvision, and what can I shed some light on.
Was the Star Trek the first licensed game for Microvision and for all games, period?
I think it was. I don't think anybody had gone to them to license that before. There wasn't a particular game, so we just licensed it and then built the game around the name. But they licensed they licensed a lot of the Centronics games. Did not license Asteroids, and strangely enough, that never wound up as a problem. Sure.
I have both your systems, and they're awesome. But I just wanted to ask you about the hum of the Vectrex. When I turned them on, they all seem to hum. And was that ever considered a problem, or?
It was. It wasn't. We can say this. It wasn't a design problem, since none of the prototypes did it. We think it was a manufacturing issue.
Yeah, certainly as people have gone through the Vectrex over the years, we've seen some of the units from, let's say, Taiwan or Hong Kong, or just the different manufacturing facilities, and even the runs have slightly different grounding issues with them. Some of them are perfect and they don't hum at all. You can bring them right out of the box, and right out of the box they were perfect. You go online and you'll swear that theirs has been perfect from day one. The rest, it's the Vectrex hum. It's part of the personality of it. And after a while, when you fix your Vectrex not to hum, you almost seem to miss it after a while. Almost.
This is his personality. Anything else?
I have a question. You were discussing the old Magnavox patent on home video game system, how much money they made. None of the companies you're involved with had any kind of patent on handheld LCD that carried forward that made anyone a lot of money?
The question was, did anybody have patents on handheld LCDs? No. We were breaking new ground then. When you're breaking new ground, it seems that you recognize it later. You don't sort of recognize it at the time because it seems obvious you're doing it. But there was really very little. They were thinking of graphics displays. People talked about graphics displays, and in the future we're going to have graphics displays. The one point that everybody ran up against is that they wanted to control every dot all the time. And that was impossible at the time. We said, so control 10% of the dots. But the 10% moves around the screen, that's fine. And that's what made it go. So no, we never had any trouble with that.
Knowing what you know now, would you have done anything different in designing the Microvision?
Yes, indeed. A couple of things. One is the size of the unit. That was an area where it wasn't clear that things that were small and unique were valuable. So the Microvision was intentionally much larger than it had to be. If you remember, the cartridge has the color overlay, and a little place for the chip, and then the rest of it's just plastic. The thing is at least twice as big as it had to be. We argued, but they were paying the freight, and it was their judgment that in being that big and in a box on the shelf and in the commercials, it looked like more value if it was larger. So I would have made it smaller, and without any question, I would have licensed a number of things, Space Invaders and other things, because since it was plowing the ground in handheld cartridge area, there was virtually every game you could have licensed. So that.
Yeah, I wanted to ask about the way sort of that different industries perceive the video games. You mentioned going to Kenner with the Vectrex, and they're saying, oh, well, and you said, well, they were a toy company, so they didn't want to get involved with this. But of course, there were a bunch of Mattel and Milton Bradley, and there are many toy companies were involved. And I'm sort of interested to know how much video games, I mean, I guess no one could figure out what they were exactly, but how much were they perceived as toys, or how much were they thought of and sort of brought out in along with toys and sold through toy retail channels, and you know, to what extent did they fit in that industry or not?
The question was, paraphrasing real quickly, that were video games considered toys, or how were they treated? And they definitely fit into the toy channel at the time. The people producing them, Atari went through the toy channels, Parker Brothers, we did a lot of business with Parker Brothers. Parker Brothers and Milton Bradley were separate at the time. Parker Brothers is Monopoly, Risk, Clue, just an old line toy company, and they had a backer. They had been bought by, and was it Quaker Oats? No, Quaker Oats was Fisher Price, wasn't it? I've forgotten. One of the big food companies had bought Parker Brothers and said, their MBAs, and correctly so, said, this isn't something new, it's big, get into it. And Parker went in a huge way. We ended up doing a lot of work for them. Cubert and a bunch of other things. And so Parker had its own channels, and this just added to the channels. In the time since then, it's separated out and has become clearly very separate. You go into a store and toys and video games are separate, and video games have threatened the toy industry a great deal. It used to be in days of old, they said that by the time a young lady was 10 years old, she'd had 11 or 12 Barbies. And now you don't sell Barbies much more than 6 years old, something like that. There's occasionally. Same thing with other toys. You don't so much buy toys for little boys who are 8, 9, and 10 anymore. Buy video games and other things. So it's a separate industry. It's really threatened and made problems for the toy industry.
I don't know if you know the answer to this, but in the early days, how did leather companies get into electronics? What was with Tandy and Coleco?
You talk about Connecticut Leather Company. The question was, how did Tandy and Coleco and leather companies get into the toy business? Coleco, which stands for Connecticut Leather Company, got in, they just branched out and started doing some toy things, and for whatever reason, really very early on picked up on the idea of video games. So they were, as you well know, preceded Atari and everything in there. The dedicated console games that they were doing. That was a wild bunch, the Greenbergs. They were crap shooters, and they try it and fail, oh, come back again. So it was finally with the Atom computer they didn't recover, but along the way the Cabbage Patch Doll did pretty well. So, and Tandy, well, that's Radio Shack, right? So that's sort of a natural for Radio Shack to get involved, and they're still just a retailer. I don't think they're that much in terms of game development.
Can you talk more about your work environment and the group of guys you worked with? Was it, you had a product in mind, and then you decide how to make that product, or someone comes up with an 8-feet width coil, or deflection board, and then you figure out what to do with it?
No, we were reasonably serious inventors, and my personally, background-wise, went to undergrad school at Virginia Tech. Glad they survived and have done very well, and I'll be back there in a couple of months. And graduate school at Caltech, and I was going into the aerospace industry. And I did work for TRW on the LEM module, which was that's a whole other story. You know. The LEM, just a quickie on that, the LEM rocket, the lunar module rocket engine. You know, a rocket is a controlled explosion, and they perfected it over the years from Goddard on down. You put in fuel, light, it blows up, and it keeps blowing up at the same rate. That's a big deal. And it's very carefully metered in. The lunar module was a throttleable rocket engine. And so it would go from 10% to 100%. And it had, of course, it wound up with several areas of combustion roughness. After they made it quit exploding, then it was just roughness. And they wound up, as I remember, with 3 roughness at 65, 37, and 20 or something like that. They managed to get one at 20 and 65 they designed out, and the one at 37 they couldn't do anything with. The problem is hover is 37%. So they actually moved it. The only thing they could do is move it. And when it went to the moon, it had combustion roughness, bad combustion roughness at 58% or something like that. And it was just a sign to do not run at 58%. Anyway, so one day after being at TRW and having interviewed Mattel at, when I got out of, graduated from school, Mattel called back, said, "Are you ready now?" I said, "Yes, I'm ready." And I went over there and worked on a bunch of projects. Fascinating stuff. The toy industry is much more complex than it would seem to be. And I was lucky to be an aerospace engineer and go in there. I think every aerospace engineer thinks, well, if all goes wrong, I can go work in toys. That's just not true. In there, but then left there and started my own company. And by the time we got involved with this, we started, our initial effort was to do some Atari games. You know, it wasn't very popular with Atari, but to do some of that, and then it quickly became some other things to do, and we were doing toys in parallel with that. And we developed a group of, at its high point, I think, was some 40 people, 15 in Palm Bay, Florida, right outside Melbourne, Florida, and the balance was here in Santa Monica. And it was a really happy-go-lucky, passionate group of programmers and designers and graphic people and toy designers mixed with video game engineers. And I was sort of the inventor of the group, and the company was called Western Technologies, and I had a separate little entity called Smith Engineering, the inventor. And so I went around talking to people, toys and video games. What do you want? What would make it work? And the key to inventing things is to solve somebody's problem. You don't go and you make some coils and things and say, what is this good for? You go and find out, what does somebody want? And more importantly, what will they pay for? And that's how we eventually got, I told you on Vectrex, we got from the little CRT to the mini arcade. We would visit with Kenner maybe once every 2 or 3 months, maybe even more than that, on the projects we were working on. So we started talking about this. If we could do this, how would you like it? Yeah, great, wonderful, bring it on, you know. And we actually were able to get them to give us money to develop the idea. And so we did that. So we put some of our own in. They gave us advanced royalties. We developed it to a point, and they said, nah, isn't going to work for us. I can't tell you all the reasons now, but it turned out great because GCE was a great supporter of it. And they were a very freewheeling group, could see the potential in it. And so these 25 guys, we had I think at least half or 2/3 were programmers doing the game, and the rest were the hardware engineers doing the hardware. And the people in Florida, all of those were just the programmers. So it was a wonderful time. We had lots and lots of fun. Worked impossible hours, and as I mentioned, this one of the guys on our staff named Jerry Carr. He's really a genius at what he does. He's got other problems, but he's a genius. And he would get stuck on something, and one of the things we would do is usually about 10 o'clock at night, just take a walk around the neighborhood. It can't be done, it can't be done. So we'd walk and walk and walk and walk and talk, and by the time we got back, he said, I don't know, leave me alone. And I'd come in the morning, and he'd solve the problem. And it was that kind of environment. Exciting to be with, exciting to see it go.
What have you been doing since the crash?
We went back into toys right away. Downsized, way downsized. And went back into toys, and came out with several things. We had done toys all along, but the thing that broke us out of that was a doll for Baloo called Baby Talk. And it sold 1.2 million pieces over its lifetime. It was just a talking doll in an era when you could make talking dolls and sell them for $59. Remember Teddy Ruxpin, sort of that era in there. So that spurred us on to a number of other things. And then in parallel with that, as you know, Nintendo got in and started selling their games. And if you remember, Nintendo was selling it half game, half toy. At the time, it was a robot that would stack all this stuff. And the commercials were more of the robot stacking the stuff than the games the Nintendo unit could play. And so they, despite trying to get involved with Atari, they went out on their own, did it, and by the time everybody in the retail environment here in the US said, wait a minute, they're selling a lot of product. But don't worry, it's going to go away. One more.
Yeah, did you ever put together a comprehensive list of all the games that were in development or even were finished? Because, I mean, there's like today, there's going to be another game that's going to pop up, and it's always rumor until it exists, but then all of a sudden it exists, and things like Port of France and some others have popped up over the years. Did anyone basically know what all was under production out of your group? Was it written down somewhere?
It was, but we didn't do it. It was, at that time, GCE, the Milton Bradley folks, had the list. And since then, many of you key guys, Chris and Rick and many of you others have carried the ball. I'm sort of a bystander, and amazed bystander in the attention and the success that this is getting and the things that people are doing. Blows my mind. This is the 25th anniversary. Realize that? 25 years ago, and they're still doing stuff for it.
Yeah, I've seen at one of the other game shows, I saw an application to the original game. You probably could not have thought of happening. They had one of the games feeding through a PC to a projector. And they projected the game onto the side wall of the convention center, playing it XY plot. And it was gorgeous. With all the lights on, you could still see it. It was gorgeous. And it must have been 25 by some feet. And it's just an application you had probably never thought of ever doing.
His comment was projecting a Vectrex game on the PC, going to project on the wall of the convention center. I would have loved that.
Back in the day, what did you think about the European market? About launching products and so on?
Again, as developers, we didn't get very involved in that. I know the GCE folks were very interested in that and nurtured a lot of the early stuff that went on. Frankly, I wasn't aware of it that much then, and it's only after that I've become aware how much went on and how many incredible fans there were over there, and people that really paid attention to it.
Do you know how many Vectrexes are out there?
No, I don't. I would guess a number. What would you guess?
We've seen serial numbers start at different ranges for different ones. There's someone that's rumored to have, I think, serial number 2. It popped up in Australia somewhere. But it also depends on which ones you're talking about. The Milton Bradley runs or the GCE runs. Certainly the European community, I mean, there's the Swedish one, version of the box. There's the Spanish version. There's the German version. I mean, there's a kind of a multi-language version. So from the original unit, the only one I've heard about was number 2, and the rest, who knows how many were produced when the Milton Bradley partnership took off and started distributing them on a global basis. And that's not even counting the other partnership with Bandai that had the Kuso games and the unit that came out. And it's hard to determine the final number that was, or the final amount that was produced.
I don't know at all. My gut guess is it's in the low hundreds of thousands.
Oh, probably at least.
100, 300, way more than 100, I'm sure. Maybe less than 300,000. I really don't know. We were, one of the great business accomplishments of that is that we were bought out of the product at one time. They said, oh, we're going to pay you way too much royalty. Will you take a check? I said, yes. Any questions in the back? I've been too many in the front here.
If the Vectrex is to come out again today, first, would you like to be involved in it? How would you see it as a handheld or as the same kind of design as the original one, or the things like on TV? And would you include the version again?
The question was, if Vectrex came out today, would I like to be involved as an advisor? And would it come out as a handheld? I don't know, but that triggers a comment that I hadn't mentioned, is that we took a swipe at making a Vectrex handheld. 1990? Something like that. Was it? With Clive Sinclair's, Clive Sinclair, a great British inventor, had put out a handheld TV that was a CRT, a cathode ray tube that was bent or folded, and the neck of the tube went like this, and then it turned 90 degrees to the face of the tube. And do I remember that oscilloscopes are static deflection and televisions are magnetic deflection of the electron beam? Correct. And this was a static deflection, which is quick and low power. That's a Vectrex, of course. We called them and talked to them, and they had just shut down the plant to do that. Said, don't lock the doors. We've got to talk to Milton Bradley about this. We put together one real quickly, and we piped a Vectrex game into the TV through a video. And here, it was gorgeous. This little handheld CRT vector scan playing on the screen. And nah, they didn't do it. They actually went and looked at the plant, and I've forgotten where the plant was, but we took a whack at making it into a handheld. So that, yes, I would love to have seen it as a handheld. I don't know if it could survive against all the graphic images that are there today, because the original Vectrex had some cost and capability advantages being a vector scan, which don't exist today. So anyway, yes, if it went there, I'd love to be an advisor. I don't want to do it again. I have been there and done that. Well, thank you so much. I think we've overstayed our bounds. I'm so pleased that you are interested in it. Love to continue to be involved. I'll be back again. Vectrex will be 30 years old in 5 years, and we'll probably have quite an event for that. I think Microvision will be 30 years old 2 years from now. So we'll be back to talk about the first LCD graphic screen cartridge programmable handheld game. Thank you much. Thank you. Hey, great questions.
Oh, I had the show was California Extreme Show. And, it's going to be in August this year. You should call the organizers.
Yeah, that would be fun.
And ask them if they're going to do the same thing. They're going to have the equipment there for the same thing. The projector was what was it, 100-watt laser projector. So even with all the lights on in the convention center, it showed it brilliantly on the wall. And it was just, I would love to have that. The laser beam projector. The laser beam, because it worked perfectly. And someone had a PC disc of all of those XY plot games to play on your PC. And that's what they were using with the projector. And with